Thank you, Marcia. Thank you for your kind invitation. It's great to be here. It's a great opportunity to present you our recent data. And unfortunately, Marina, I will present 2D data. Okay? And we will explain why. And also it's...
We have to survive.
Okay. And it's a tough job to talk after Steven, so thank you, Marcia, for that. So I will present you some data more focused on the CBD, the cannabidiol, than in the Dravet or IPS cells. Okay, sorry for that. So I'm gonna talk about Dravet syndrome, and I would like to start it to show you the kids that have or had this disease. So I check on this foundation, and in this website you can donor, you can check for research fundings and things like that. But for me, more important was to really get one example of Dravet story. So I select Everett story. Sorry about the long slide, but it's just to show you, this is a summary of 8 months of life of this kid. And what this kid had already lived in this period of time is horrible, is devastating. So basically, he is an exception because since he got the diagnosis of Dravet, he started to be medicated with a combination of different drugs, and he is responding well, okay, at least since 2012. And this is an exception in Dravet syndrome, okay? So basically, Dravet, it's a devastating infantile onset of epileptic syndrome. It's a high incidence, this is a US American epidemiology data, and also a high mortality associated with the disease. And as the case that I explained to you earlier, it started around 6 months of life with a febrile status epilepticus, and then start to get seizures that could last at least 1 hour. Most of these patients got this mutation in this gene, SCN1A, and is related to GABAergic interneurons, and it causes influence the action potential of these neurons and affect different excitatory control over other paraneurons. So, as I said, most of the patients are treatment resistant for this epileptic, and for this specific population of patients, there are no current US Food and Drug Administration approved therapies, which is horrible. But since the beginning of our human culture, cannabis-based therapies have been used to treat this kind of disease, epileptic at least. And only the last few years we have begun to collect really good clinical data from trials that could really show the benefit of CBD. And as I said to Marcia, I sent her just yesterday my slides that I took for Brazil, because Rafael Mechula was the researcher that described the first structure of THC and other compounds as cannabidiol. That now is the in vogue molecule to treat Dravet syndrome. And I had to change my presentation because last Friday, the very first good clinical trial showing the benefit of CBD supplementation in Dravet patient came out. It was last Friday, so it's really, I'm serious. Thank you, man. So basically, in this control placebo clinical trial, they really demonstrated the benefit of CBD in those patients that has they are completely unresponsive to other therapeutic approaches. And they showed in this study almost a 50% reduce in the crisis, in the events, but again, several different side effects associated with this treatment. And things like 10% of the patients showed high convulsion in response to CBD. So basically we have to know study way much better the real effect of CBD in those patients. And in this context, I would like to tell about focus on CBD and new alternative experimental models. So basically my lab, from the past 3 years, 2-3 years, we've been working with CBD, but from a toxicological point of view, using 2D cell models. Okay? Because historically I came from the cancer field, and I got a position in the neurochemist department from South Brazil. And I said, okay, let's start to play around with my colleagues and do some neuroscience. And we start to work with these neuroblastoma cells. It's a human neuroblastoma cell, SHSY5Y, that can, when you apply the really simple differentiation protocol, these cells, they got the neuronal morphology, they got really increased in the neurite density, and they start to express several different neurological markers, such as tyrosine hydroxylase, neuron protein, analyzed neuron specific, and they begin to decrease the expression of nesting that is an undifferentiated cell marker. So in this time we were testing different protocols, different times of incubation to get the better way to differentiate this neuroblastoma cell into a human neuron-like cell. Okay. And recently we showed this Fernanda, she finished her PhD, working in this specific cell model, and she showed that this cell model, when challenged with 6-hydroxydopamine, because it's a dopaminergic neuronal cell, the toxicity of 6-hydroxydopamine is dependent on the specific transporter of dopamine in the free radical production, in the oxidative stress, and also in cell death. So we were proposing that time to use this as a simple in vitro model to study some aspects of Parkinson's disease. And they look beautiful in the page. Thinking about the toxicological approach of CBD, we tested 2 different approaches. One using the mature neuronal cell, when we applied our protocol, differentiate the cells, and then challenge them with different doses of CBD and evaluate different endpoints, toxicological endpoints. Or we expose these cells during the protocol of differentiation as an in vitro neuronal developmental toxicity model. So with the same cell model, we can get 2 different information regarding the mature neuron and the developmental of this neuron. Because we believe that some of the machinery that you activate during this process could be reflect the machinery that iPS cells or progenitor cells also use to get the neuronal phenotype. This was the master thesis of Patricia. And one interesting topic regarding the CBD, the cannabidiol, or the endocannabinoid system is that during the neuronal differentiation of this cell line, at least the CB1, the receptor CB1, got increased during the differentiation process. And this is also, it's something that physiologically happens during the development of the brain in physiological conditions. So Patricia first was looking for the precise dose that these cell lines tolerate as a mature neuron. So we did a dose effect assay with different concentration of cannabidiol, and you can see here the tumoral phenotype. They love CBD. And also, if you look at the literature, there's many reports showing some anti-tumoral effect of CBD. In our hands, they simply love it. And as you see in this dose response curve, the neurons, they are very sensitive to these molecules. Of course, I'm talking about micromolar concentration of CBD. So with this assay, we select a sublethal dose of CBD, which presents some antioxidant effect in vitro and also in our cell system. That was 2.5 micromolar of CBD. And then, with the first protocol, we differentiate the neurons, incubate them with the highest sublethal dose, wash them, and challenge them with different redox active toxin, hydrogen peroxide, 6-hydroxydopamine, and 2 glucotoxins. It's methylglyoxal and glycoaldehyde. And as you can see here, at least this high dose did not alter the levels of the cell viability, the neurite densities, but was not effective as a neuroprotection against these challenges, these 4 different challenges. But, Patricia was, okay, I need to finish my master, I have no data. No, this is data, negative data as compared to all the literature. People saying that, okay, CBD is perfect, it's antioxidant, it's good for everything. You put in you can have it on your breakfast, kids, everything. And it was tough to convince her about the relevance of her findings. But then, when we expose these neuroblastoma cells to CBD during the neuronal differentiation by our protocol, we also could not find any changes in neurite densities or in some redox parameters. But as you can see here, when we challenge these cells with sublethal doses of the same redox active compounds, we saw a really increase in the sensitivity of these cells when treated with CBD. So basically our data show that CBD per se in our cell system had no effect, no bad effect or good. We could not see any changes in the antioxidant capacity. But there is some side effect that when you challenge the cells, you can clearly see the increase in toxicity with all compounds that we test in vitro. So basically, our idea in that time, Patricia, last year, I believe in September, she came here, we started talking with Stevens to move forward to a more physiological, more relevant cell system to study Dravet. So she came here in September, she got trained with the Steven team, and Steven team, they produce at least 3 types of Dravet iPS cells, and we got this one to study. It presents the precise mutation in the gene that causes Dravet. And okay, we came back to Porto Alegre, we started to order all the reagents, and basically it took us 8 months to got all the reagents. And most of them are expired already. So we are starting again the cycle with the company. I'm not saying that I'm just showing why we could not. We are not living in São Paulo and Rio. We are in Porto Alegre, south part of Brazil. And sometimes people call us masochists. Don't do science there, but we are not masochists, but we believe that we will perform this experiment as soon as possible. Okay, there is several different approaches using iPS cells in the Dravet syndrome. From 2013, we can see some reports. But as I said, my interest in this research is focused on the CBD. And we've been collaborated with Rafael Mechula, the researcher from Israel who described THC and CBD. And we are getting some different compounds derived from the CBD. And we are working together using our, how to say that, INCT in Brazil, from CNPq. And we believe we have these molecules, and we have a panel for 40 other completely new models, drugs from CBD. So our idea in some of them, as I show you here, the fluoro-CBD, presenting animal models like really increased enhancement of activity. So we believe that maybe applying the same approach that we had with the SH cells, using iPS cells like mature neurons or neurosphere, and during the differentiation process, we can show this side effect of CBD, and most important, we can compare with different others molecules to select one that present the benefits of CBD in Dravet patient, but not just undesired side effect. I would like to thank my collaborators, also Kripa from USP. Kripa came from the same university that during the 80s, Carlini and Cunha described the first beneficial effect of CBD in epileptic patients. And he is also in our group. I would like to thank Stevens and all, Marilia also, and all the crowd that helped us with the cells, helped with the training of Patricia, and Giancarlo that is now modeling the binding, potential binding of CBD and the other molecules in the CB1 crystal structure. And again, I would like to finish with the kids, and thank you very much.